Welcome Year 10s to this next video. As you can see, we are going to do a bit of a review of gradient. The gradient is also sometimes referred to as the slope, so I've written that up the top. You have done this before, and we are going to use the same notation that we've used for the distance between 2 points and for the midpoint of an interval. We're going to be using that notation of x1, y1, x2, y2. So just as a quick review, the gradient is a measure of the steepness of a slope. So if you were looking at two lines and they were both, say, a positive slope and one had a larger gradient, then of course that means that it is more steep than the other. To calculate it, we do look at how much the line is rising over how much it is running. So how much is the y values changing? How much is it going up, in other words, compared to how much it's going across? So the change in y over the change in x is another way of looking at it. In a formulaic terms, we could look at it in terms of for change in y, that would be y2 minus y1, where obviously these are your y coordinates. And for the change in x, it would come up as x2 minus x1. So for this one here, as you can see, I've drawn one already. We've got a slope. You might have a look at it and go, well, it's going to be a positive slope because I can see that the y values are increasing as the x values are increasing. And what you can also do, if you wish, is you can label these as x1, y1, x2, y2. Doesn't matter which one you do as x1 or x2. X1, y1, x2, y2. Oops, there we go. All that matters is that, of course, you label them accordingly as the x and the y. So the gradient of this one here, if I take my y2 value to begin with, it's going to be 8. y1 is 2. And the change in the x's is going to be 8 minus 4. And then we'll evaluate that. So that's going to be 6 over 4. Or when you simplify that, 3 over 2. What this is saying is that for every 3 units that you move up on the y values, you will move across 2 values to get back to your line. For every 2 values that the line is changing in terms of x, the line is rising by 3. So sometimes it will be written as a decimal, so this could be written, say, as 1.5. But of course, because we like to keep things in exact form, I'll leave it like that. Any fractional gradients that you get, you must simplify them. So that's a positive one just there. Now, of course, we can get negative slopes as well. I might just go to my second slide here. So I've used the same numbers here, but as you can see, the line is actually, as you move across the x values, the y values are actually decreasing. And that's what a negative slope will look like. We'll just change colours. Let's do our y2 minus y1 over x2 minus x1 again, because that's our rule for the gradient. And of course, if you want to, you can label them. Okay, so y2 minus y1, x2 minus x1. Just be careful with your negatives, of course. All right, 2 minus the 8. Now I've got negative 4 minus negative 8. So that's negative 4 plus 8. And then we simplify. So as you can see, because I've used the same numbers, I do have the 3 over 2, but this one was negative, so I've got the negative out the front. Okay. I just want to talk briefly about another couple of types of slope that we can come across. And to do that, I'm going to use this little drawing, which we call Mr. Slope. As you can see, Mr. Slope has got on his left eyebrow, I should say, he's got a positive slope there, and I've marked his eye is actually a positive symbol. The other eye, the right eye, is closed and it's a negative symbol, and that shows you the negative slope on that particular eyebrow. Mr. Slope, though, has two other features about him that links really nicely to the gradient or the slope, and that's his nose, which you'll see is a vertical line, and his mouth, which is a horizontal line. So I want to talk about vertical and horizontal lines and what their slope would be. If you have a look at the nose of Mr. Slope Man, you'll see that he's got a little U underneath. So that's part of his nose. And the U refers to this bit, undefined. Now, I just want to explain that. If you had a vertical line, it means that you've actually got, I'm going to make up some coordinates here. Say the coordinate was 1, 5. Yeah? And so just at that point there. If you have a vertical line, the coordinate down here will actually have the same x value. So the coordinate down here could be 1, say 2. So what you'll see is the same x coordinate. When you see that, you know you've got a vertical line. Well, you could draw it in and you'll see that it's vertical. And what happens when we do the gradient of this is something that in mathematics we don't really like to see. So here we go. We're going to do the difference in the y values. So it doesn't matter which one we choose, but 5 minus 2, say. On the bottom here, what you'll notice is because we've got the same x values, we get this bit. We get a 0 as the denominator. And we don't like that. The reason I was saying we don't like it is we can't actually calculate that. That doesn't give us, doesn't exist. It's what we call undefined. So my point is, if you see a vertical line, you're asked to calculate the slope of it, your answer is actually going to be undefined. So it's not a slope of 0. Sometimes that's a misconception. It's not a slope of 0. Because this is a vertical line, we can't actually define its slope. Horizontal lines work a little bit differently, as you can see here, and you'll see on Mr. Slope's face that there are 2 little zeros either side. Well, they don't actually look like zeros. It should look a little bit more like this. But that's okay. Now, the reason that a horizontal line will have a 0 slope is if I'm just going to make up some values again. Say this x was 1 and y was 1. At this point over here, because it's horizontal, the y value is actually going to be the same. So say the x value here was 5. So if we do the slope of this one, or the gradient, when we do the difference in our y values, now this isn't a good one. Oh, no, it'll work. 1 minus 1. Notice when I do difference in my y values, I'm actually going to get 0. Now this is equal to 0. So a 0 in the numerator is okay. 0 in the denominator is not okay. When you have a 0 in the numerator, you're going to get an overall value of 0. And therefore, when we have horizontal lines, they will have the same y coordinate they will be horizontal and their slope will be equal to 0. So just a couple of special cases there. In terms of calculating the gradient, I'm confident that with a bit of practice and review, that won't be a problem. Do remember as well that sometimes you can be given the slope and asked to solve for one of the unknown coordinates as well. So I'll leave this one here. In our next video, we are going to look at a couple of special cases, and that's parallel and perpendicular lines.